We are solving equations. The only thing different throughout Learning Target 9 is what the directions say. So yesterday it said to solve the equations from 0 to 360 and then from 0 to 2 pi. So you did degrees or radians depending, and it had to be in that group. Like it had to be on the unit circle. Yes? Today we'll do two different ones, and then again, it's still solving though. It's just because the directions are a little bit different. So this one says to solve each equation for the principal values of x. Express your solutions in degrees. On the first one, I think it's actually, let's skip the first one and come back to it. The other two are really easy. So let's start with 2 sine x plus 1 equals 0. How do you solve that? Subtract 1. And then divide by 2. So I have sine x equals negative 1/2. So like we were doing yesterday, we're looking for x is equal to negative 1/2. But the directions say to use principal values. We've talked about principal values once before, back in Unit 2, when we did capital S, capital C, and capital T, sine, cosine, tangent. So the principal values, if you need to take note, for sine and for tangent are from negative 90 to 90. The principal values for cosine are from 0 to 180. So principal values is just limiting your answers a little more than it did yesterday. Yesterday it had to be on the unit circle. Now it's saying it has to be in specific quadrants. No, you will have to know the principal values. Mm-hmm. Mm-hmm. So start looking at the unit circle and looking for where sine x, or where x is, we're looking for what angle measure, what x is going to be for sine, where sine is negative 1/2. So again, this is principal, so it has to be between negative 90 and 90. So quadrants 1 and 4. Okay, so what's wrong about saying 330 degrees? It's not between negative 90 and 90. So we have to change those. Remember, we changed 330 to negative 30, and we changed 315 to negative 45, and so on and so forth. So this is going to be at negative 30 degrees. Right. That's the answer, yes. Question. Again, the negative 1/2 is at 330 degrees, but 330 is not between negative 90 and 90. We changed those values in quadrant 4 to the negatives of quadrant 1. That's what we did. Yes. Not what we're talking about right now. Okay. Questions about this first one? All right, on the second one, or the end one, we'll go back to the very first one in a second. So on this one, what are we going to do first? Add the square root of 3. And then we are going to divide by 2. So we're looking for angle measures where cosine is the square root of 3 over 2. And again, it's principal value, so it has to be between 0 and 180. So that happens at 30 degrees. Cosine is the square root of 3 over 2. That only happens at 30 degrees between 0 and 180. Everyone okay with that? Okay, can I erase what I have so far?
Oh, wait, how do you, why did you put negative 30 because it's negative 1 half?
All right, so on the first one, you might think that you need to like add the 1/2 cosine x or something. But then you're going to have cosines of different sides, and you'll be tempted to divide them. That's one thing you can't do here. You can't like divide out a trig value. Because by dividing something out and making it go away, then you're going to miss answers. So we don't do that when we're solving. We do a lot of factoring. That's what we're going to do this question. So what are we going to factor out? Cosine, because there's a cosine in common. So we take the cosine out, what's going to be left over?
Sine, cosine.
Sine x minus 1/2. That's what I was saying. Like if you were trying to solve this equation, you tried to like add 1/2 cosine x to the other side. Like that's what you guys would do. You would add 1/2 cosine x to the other side. You would divide by cosine, and then the cosines would cancel out. In doing that, you've eliminated possible answers because you've eliminated a whole entire function. So really, you just try to solve them in ways that will keep all of the functions there. So if it's set equal to 0, generally you're going to try to factor anyway. All right, now, just like yesterday, using the zero product property, each one of those factors gets set equal to 0. So we have cosine x equals 0, and I have sine x minus 1/2 equals 0.
Now you can factor add the 1/2.
Right, so on this second equation, I need to add the 1/2. But now I have two different angle measures I'm looking for. Again, we're just looking for principal values. So I'm looking to see where cosine x equals 0, but only between 0 and 180. So that's at 90 degrees. It is nowhere else between 0 and 180. Ever go with that? Then we're looking for sine x is a half between negative 90 and 90. 30.
You have to distinguish that here, right?
Hmm?
You have to distinguish which one was cosine and which one was sine.
No, because they both would work. Like they're both, if you put into this equation, would equal 0.
So if you have two different functions like sine, cosine, and answers, so you could just have like cosine and
Well, if you had cosine, you could have multiple like we did yesterday. It depends on the directions they're asking. But yes, if you have two different functions, you're going to have two different answers you're going to have, because at least two, because you have to look at two different function values. Is everyone okay with this part?
Yeah.
Okay. All right, the second part of this we're going to do today, it asks you for all real values of x. So think with me really quickly. The unit circle goes from 0 to 360, right? But you could keep going around it over and over and over and over again, right? You can get angle measures bigger than 360. So you can keep going around over and over again. So when it says all real values of x, we would have like actually infinite number of answers. We're going to generalize that with a little plus little 2 pi k, but we'll get to that. But we're talking about every single possibility. We're still doing the same thing we've been doing though. So for the first one, I have sine 2x minus cosine x. What should I do first? That doesn't help. Sine 2x is an identity.
No.
So 2 sine x cosine x is what sine 2x is. That's one of those identities on the red formula sheet. It's a double angle identity. So you're just going to replace the double angle identity with what it's equal to. Right, so now there's a cosine in each term, and I can factor. right, so what do you do now? Set cosine equal to 0 and set 2 sine x minus 1 equal to 0. I'm going to go ahead and solve the second equation real fast. You would add 1 and divide by 2, right? Now, this isn't principal values anymore. We're talking about the whole entire unit circle. And we're going to express these in radians. Just because I decided we're going to. Instead of degrees. Generally, just because when you talk about all real values, you generally talk about radians, not degrees. It doesn't really matter. It doesn't matter. So first we need to find where cosine x is equal to 0. Just on the unit circle. Pi over 2 and 3 pi over 2. Now we're talking about all real values. So that means if you're at pi over 2 and you hit around the unit circle again, you hit it again and again and again. So what we put on here is a 2 pi k. That means whatever number you put in for k, like 2 pi is a full rotation, right? So however many rotations you want to go, you're going to keep hitting that same place, and cosine is still 0 there. Right, so same thing on the second one. Someone during second period also asked if it was okay, since on this one it repeats every 180 degrees, you could combine those and just say x equals pi over 2 plus pi k, but it doesn't matter. You can have both of them. It's not wrong. So you can either have the 2 in purple or the 1 in black. You don't need all three. Okay? We're not talking about principal values anymore. All right, on the other part, sine x equals a half. So where's x? What angle measures where sine is a half? And we'd have to have plus k plus 2 pi k. You could not condense this one because it's not a whole 180 degrees. It's not consistent. There's like 120 degrees between them, but then the next time you'd have to go, the next time you'd have to go 240 degrees. So it's not consistent. You'd have to do it separately. Questions on this first one? We're still solving the same thing. Can I clear this up? All right, on the next two, though, I need you to think a little bit differently. That's why I included these. No. I asked you to think. On this next one, I've got tangent squared x plus 2 tangent x plus 1 equals 0. So it's nice that everything is in terms of tangent. But some of you guys would think to subtract 1 and then factor out a tangent. If you do that, you can't separate them instead of making them a -1. That only works when it's set equal to 0. It's called the zero product property. So we have to do something so we still have it equal to 0. So you need to think of this as x squared plus 2x plus 1. You guys can factor that. Mr. Scott called the Loy thing. You can factor that. That one's not hard to do. But instead of having x's, you have tangent x's. You're looking for two numbers that you can multiply to get 1 that add up to be 2. So in this case, what two numbers multiply to give you 1 and add to be 2? 1 and 1. So you're going to have tangent x plus 1 times tangent x plus 1. All right, if you can't move things around and factor like we've been doing, then you're going to have to factor. Right, so if you were just factoring this right here, you get x plus 1 times x plus 1. You're just replacing the x's with tangent x's. You have two of the same factors, though. So I need to set both of them equal to 0? Do I need to do that? No, just one. That's fine. Since they're both the same, you only get one answer. You don't have to do this once. I put the tangents back in because the original question has tangent.
Now,
So they have to be there.
now then, if we were trying to do this, like we would get a thing and try to work this.
Right, and then you just put them back in.
Okay.
Yes.
We could get tangent x plus 1 equals 0.
Right.
There's 2.
If they're both the same thing.
It's like 1 to 1.
So it's like, well, no, it's just you would have tangent x plus 1 equals 0, and you have tangent x plus 1 equals 0. If you solve them, you're going to get the exact same equation twice. You don't get two different answers.
Yeah.
So how do I go about solving this part? Subtract 1. So on your unit circle, where does tangent x equal negative 1? 7 pi over 4 and 3 pi over 4. So again, here, they're 180 degrees apart. So you can just do both of them plus 2 pi k. Or you can condense them into x equals 3 pi over 4 plus pi k. Tangent always consistently repeats every 180 degrees.
On a further test, you write x equals like 3 pi over 4. Do we have to specify 3 pi?
If it's asking for all real values of x, yes. If not, you've only given me one value of x, but it says all. It's like infinite answers. Questions about that one?
We can do
Right. Questions? Can I erase this? One more, and then I'll be done. On the last one, I've got cosine squared x plus 3 cosine x equals negative 2. If you try to factor the cosine out, it's still equal to negative 2, so you can't separate it because it's not equal to 0. So you'd want to add 2. Yes, that way it equals 0, and you can do something about it. No, like this is 3 cosine x's. It's like having 3x. If this wasn't being multiplied, there would be a plus sign in between or a minus sign. But it's not. It's being multiplied. So again, if you can think about this without the cosines, you have x squared plus 3x plus 2 equals 0. So what two values multiplied to give you 2, but it'd have to be 3? Right, you'd have x plus 2 and x plus 1, but we're actually talking about cosine x's. So you don't really need any of the, like this part right here, you don't really need to have that written down. You can, but you don't have to. Like a multiply dot. All right, so when you have the zero product property, you multiply. You set them both equal to 0. Set them both equal to 0. Solve them both. Now, on the unit circle, can cosine x equal negative 2? No. Cosine x is always between 1 and negative 1. So this cannot exist. No, like on the unit circle, like cosine x is never going to be negative 2. If you start looking at the numbers, they're all between 1 and negative 1. They're never going to be larger. No, cosine, like cosine, no matter if it's on the unit circle or not. If you find the cosine of any angle, it's never less than negative 1 or more than 1.
So it ever says 2 or 3 or 1.5?
For cosine, you can't do that. Also can't do it. But if you're talking about secant or cosecant, you could. Because, like, for example, if you look at cosine of pi over 3, that's 1/2, right?
Hold on.
Sine of pi over 3 is 1/2.
Yeah.
But if you were doing secant of pi over 3, that would be 2, right? So you can get 2's and stuff elsewhere, just not for cosine. So that first part can't happen. What about cosine x equals -1? What does x equal? Cosine. Pi. Plus 2 pi k. Questions about that one? Yeah, this one, I mean, there's nothing else you can do. You can't, I mean, there's nothing, if you try to do the inverse of that in your calculator, it'll tell you there's an error. Like, it does not exist. Not there. It's the same thing. Like, using inverses is the same thing as looking at your unit circle. Questions on the floating target in general?